Hello guys, in this video we are going to discuss the solution of the problem minimal cost. So let us look at the problem statement. The problem statement says there is an array of heights of a stone and Geek is standing at the first stone and can jump to one of the following stone, I plus 1, I plus 2 or I plus k stone, where k is the maximum number of steps that can be jumped and cost will be absolute of hi minus hj, is incurred, where j is the stone to land on. Find the minimum possible total cost incurred before the geek reaches the last stone. So for instance, if this is the height of the stone which is given to us and the maximum number of steps which we can take is 3, then the minimum cost which will be incurred is 30, and that minimum cost can be obtained by jumping from stone 1 to stone 2 and then from stone 2 to stone 5. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say the value of k which is given to us is 3 and the height of the stones which are given to us is this. And we need to find the minimum cost it takes for us to reach from stone 1 to the last stone. So the way we are going to solve this is, let's say this is the height which is given to us, and right now we are at the starting position which is stone 1, and from here we can make a jump of 3, a maximum jump of 3, which simply means from 10 we can make a jump of 1 and we will land on 30 height stone. So in which case the resultant array will look something like this. Similarly, if we make a jump of 2, that will bring us to this stone and the resultant array will look something like this. Or we can make a jump of 3, because of which we will reach to this position and the resultant array will look something like this. And now let us recursively perform the same operation from each of these combinations. So to begin with, let us say we are at this position, and from here again we can make a jump of either 1 or 2 or 3. So let us make such jumps. So if we make a jump of 1, we will be at this position. If we make a jump of 2, then the resultant array will be this. And if we make a jump of 3, the resultant array will be this. Similarly, when we are in this array and we are at this position, we can make a jump of 1 or 2. Jump 3 is not possible. And if we make a jump of 1, we will be at this position. And if we make a jump of 2, we will be at last position. And the same goes for this array as well. So from this array, we have just one jump possible, because of which we will reach to this position. Now let's say we are at this position, which is 40th. From 40th again we can make two jumps, which is to 50 and to 20. So let's make those two jumps. So if we make a jump of 1, we will be at this position. So 50 and 20 will be our resultant array. And if we make a jump of 2, then the resultant array will be 20. For this, there is just one jump. So here the resultant array is 20. Here it is already 20. And the same goes for this as well. There is just one jump possible and we will reach to 20. Here also it is 20. Here also it is 20. And then finally we have just one array which is left, which is 50, and from 50 again we have just one jump and we will be able to reach 20. So in a way, what we have done is, using this tree, we have plotted all possible combination or all possible jumps which we can take. Now in this all possible jumps, all we have to do is we have to find the minimum cost jump. So now let us compute the cost of each of the jumps. So if we take this path, in order to reach to this position, we are taking a jump of 20, 30 minus 10. Similarly, if we are at this position, we are taking a cost of 10, 40 minus 10. And if we are at this position, again the cost is 10. Over here the cost is, so if we compute the total cost we took, if we take this branch, then the total cost will be given by 20 plus 10 plus 10, which is 40. 40 plus 30, which is equals to 70. So the total cost over here is 70. Now let's calculate for the other jump. So from here, if we come to this position, the cost will be 20. To this position, the cost will be 30. And if we compute the total cost, that will be given by 20 plus 20 plus 30, which is equals to 70. Folks, let us calculate the cost for this branch as well. So here the cost is 20. So the total cost it incurred is 20 plus 10, so 30, and 30 plus 20, which is equals to 50. So far the minimum cost we have obtained is 50. Now let's proceed forward. Now let us calculate the cost of this branch. So in order to reach this, we will be taking 10 units. We have reached the last part. So here the total cost which incurred is 20 plus 10, which is equals to 30. So far the minimum which we have obtained is 30. And if we explore other branches, you will realize that the cost is greater than 30. Which simply means this is the branch which is going to give us the minimum cost, and that is what we are going to return. So for this case, we are going to return 30. So now with this brute force solution, we realize that we are solving the same problem more than once. So the problem which I am talking about is, let's take a look on this problem, 40, 50 and 20. So 40, 50 and 20, this problem we have solved it over here, and the same problem we have also solved it over here. Similarly, if you look into this sub-problem, which is 50 and 20, this sub-problem we have solved it at multiple times. So for instance, we have solved it over here, we have solved it over here. So from here, what we can deduce is we can use dynamic programming in order to solve this problem. Now let us see how using dynamic programming we will be able to solve this problem. So let us say this is the array which is given to us, and this is the additional DP table which we are taking. And initial value for all these entries is set to positive infinitive, and the first entry is set to 0. Now what we are going to do is we are going to compute the minimum cost it takes in order to reach a particular stone. So for instance, if you want to reach this stone, the minimum cost at the moment it takes is 20, which is 30 minus 10. And if you want to reach to 40, the minimum cost it takes is 30. Similarly, if you want to reach 50, the minimum cost it takes is 40. Now with this, let us proceed forward. Now let us say we are at this position. So to reach this position, the minimum cost I would be needing is 20. Now from this position, I can reach either 40, 50 or 20. So from 30, if you want to reach 40, the cost I will take is 40 minus 30, which is equals to 10. And then the cost which is required to reach 30 itself, and the cost which is required to reach 30 is 20. So in this way, the total cost is 30 to reach this position. And since this 30 is not less than or equals to the value which is already there, because of which we are going to maintain the same value. Now let's proceed forward. Now here let us say we want to reach 50 from 30. So in order to reach 50 from 30, the cost it will take is 20, and the cost to reach 30 is 20. So to reach 50 via 30, the total cost it takes is 40 units. Now, since this cost is equals to the cost which is already there, or since this cost is lesser than the cost which is already there, that is why we are not going to update it. We are going to maintain it as such, and we are going to move to the next element. So from 30, we can reach 20. And in order to reach 20, the cost we will incur is 10 units, which is 30 minus 20, which is equals to 10 units. And plus the cost to reach 30, which is equals to 10. So the total cost we are taking is 30, and that is what we are going to update over here. Now let's proceed forward. So now from here, we are at this position. When we are at this position, we know that the minimum cost it takes to reach to this position is 30. Now from 40, we can either reach 50 or 20. The cost it takes to reach 50 is given by 50 minus 40, which is equals to 10, and the cost to reach 40 itself is 30. So in this way, the cost is 40. Again, this is not lesser than the previous value, because of which we are going to maintain the previous value. Now let us say from 40 we want to reach 20. So the cost it incurs will be given by 40 minus 20. So this will be equals to 20 plus the cost to reach 40 itself, which is 30. So in this way, this cost is equals to 50. And since 30 is less than 50, so we are going to maintain 30 itself. Now let us say we are at this position now, which is 50. So from 50 we can reach 20, and the cost it takes is 50 minus 20, which is equals to 30, and the cost to reach 50 itself is 40, because of which this value will be equals to 40 and the cost we will get is 70. And since 30 is less than 70, because of which we are going to maintain 30 itself. So in this way, we have computed the minimal cost, and the answer or the minimal cost to reach the last index will be given by this number, which is equals to 30, and that is what we are going to return. So we are going to return 30. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to compute the minimal cost, and an array and k is given to us. So the first thing which we are going to take is a DP table, and we are going to initialize this with positive infinity, and the size of this DP table will be equals to the size of the array. And then let us mark the first value to be 0. And then we are going to iterate on for I in range of len of array. So essentially on all elements of the array. And let's take a j and let's set j equals to I plus 1. And then we are going to iterate on j while j is less than or equals to I plus k. So how many steps we can take? So from I can take at most of I plus k steps. That is why j is less than or equals to I plus k. And j is less than len of array. And then we are going to compute the cost to reach j from I, which will be given by absolute difference of ARR I minus ARR j and the cost to reach ith position. And the cost to reach ith position is there in the DP table I. Then let's compute the minimal cost. So the minimal cost to reach jth position will be given by minimum of this cost which we have just computed or the previous value of dp of j, and then let's increase our j by 1. And in this way we have computed the entire cost, and towards the end all we have to do is we have to return last value of this dp table, which will be given by len of ARR minus 1. So that's the discussion of pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. So we have a DP table. Initially the value is set to positive infinity, and then the first value we are setting it to 0. Then we are iterating on all elements of the array. Then a jth counter, j equals to I plus 1, and then we are iterating on j. Then we are computing the cost, and then we are computing the minimal cost. And towards the end we are returning the last value of the DP table. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ solution. So the C++ solution is also the same, folks. We have a DP table. Initial value is int max. DP of 0 equals to 0. Then we are iterating on the array. And then from ith position, the jumps which we can take. For each jump, we are calculating the cost. Then we are calculating the minimum cost in order to reach to jth position. And towards the end we are returning the last entry of DP table. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.